Hello students, welcome to the fourth lecture of Newton's laws of motion. I am Lalit Midha, your physics teacher, and in this lecture we will cover three topics: rocket propulsion, bomb explosion and equilibrium condition. Our first topic is rocket propulsion, or you can say it is a variable mass system. Before starting the theory of rocket propulsion, let us see a small clip by a great teacher. Are you ready? Okay. Now let us discuss the theory of rocket propulsion. In this topic we have two different conditions. First is when rocket is moving in gravity free space. Means we have to ignore gravity. We will not consider the weight of this rocket while calculating the acceleration of the rocket. Second condition, we have to include gravitational force. We have to include gravity. Means we will consider the weight of the rocket while calculating the acceleration of the rocket. Now suppose this is a rocket whose initial mass is m0. m0 includes the mass of the fuel also. So total mass of the rocket at t equal to 0 is m0. And this mass will decrease continuously with time. Why? Because fuel is burning at constant rate dm by dt. This is mass of gases ejected per unit time, or you can say it is fuel burning rate. Direction wise, or you can say sign wise, it is negative. Negative sign shows that mass is decreasing with time. And gases are coming out with relative velocity Vr. Vr is exhaust velocity of gases with respect to rocket. Means relative velocity. Here rocket is based on Newton's third law, action and reaction. What is action? The force applied by the rocket on the gases. This rocket is pushing the gases in downward direction with velocity Vr, and the mass coming out per second is dm by dt. Because it is exactly similar to water jet case, the force acting on the gases by the rocket is Vr dm by dt. That is action acting on the gases. So gases will give a reaction in opposite direction, and magnitude wise reaction is equal to action. So the force acting on the rocket by the gases is also Vr dm by dt. That is also known as thrust force acting on the rocket. This is at t equal to 0. T equal to 0, initial mass of the rocket is m0. That includes the mass of fuel also. And this mass is continuously decreasing with time because fuel is burning out with constant rate dm by dt. Let us calculate the mass of the rocket after time t. Suppose dm by dt is 10 kg in 1 second. So decrease in mass in 1 second is 10 kg. Decrease in mass in 2 seconds, 20 kg. Decrease in mass in 3 seconds, 30 kg. So what is the decrease in mass in t second? It is t into 10. So in the same way, mass of the rocket after time t is less than m0. And the value of m is m0 minus t into dm by dt. For 2 seconds, 2 into 10, 20 kg decrease in mass. So here mass at any time t is m0 minus t into dm by dt. And we know net force acting on the rocket is equal to mass into acceleration. What is the net force? We don't have gravity. So net force acting on the rocket is due to gases, that is in upward direction, Vr dm by dt. So net force is Vr dm by dt. Mass of the rocket is continuously decreasing with time. So m, that is m naught minus t dm by dt. So acceleration of the rocket is also continuously changing because mass is changing. So acceleration of the rocket is Vr by m dm by dt. That is the acceleration of the rocket, and this acceleration is not constant because mass is decreasing. So acceleration of the rocket is continuously increasing with time. Right? This is first condition. Now let us see the second condition, in which we have to consider gravitational force also. Again, mass at any time is m naught minus t dm by dt. Now the net force acting on the rocket is not thrust, it is gravitational force also. So what is the net force acting on the rocket? Rocket is going up, so this force is bigger than mg. So net force is thrust force Vr dm by dt minus mg. This is the net force acting on the rocket. This is the net force acting on the rocket, and this net force will be equal to mass at any time t into acceleration at any time t. So from this result you can calculate the acceleration of the rocket at time t. Now one very important formula, velocity of rocket after time t. If a rocket starts with initial velocity u is the initial velocity of the rocket at t equal to 0, and the initial mass of the rocket is m naught. Here we are including gravitational force also. So mg is also acting here. Now what is the velocity of the rocket after time t? This we have to find out. We will integrate this result to calculate the velocity of the rocket after time t. But the derivation is not important for competitive exam. So I am telling you the final velocity of the rocket after time t, that is u minus g into t plus Vr ln m naught by m. What is m naught? Initial mass at t equal to 0. What is m? It is the mass after time t, m naught minus t dm by dt. This is ln. Ln means base e, log base e. You have to remember some results also. Log base e2 or ln2 is 0.69. Its value is 0.69. What is the value of ln10 or log base e10? It is 2.303. We will use these values in numericals based on rocket propulsion. Right? Next, let us see some problems based on rocket propulsion. First problem is, a rocket of initial mass 6000 kg ejects mass at constant rate 200 kg per second with constant relative speed 800 meter per second, and we have to find out the acceleration of the rocket after 5 seconds. Neglect gravity. So with time, here mass of the rocket is decreasing. It is decreasing with rate 200 kg in 1 second. So how much is the decrease in mass in 5 seconds? 5 into 200 means 1000 kg will decrease in 5 seconds. So what is the final mass of the rocket? It is 5000 kg. So according to the formula, net force equal to mass into acceleration, net force on the rocket when gravity is neglected is only thrust, that is Vr dm by dt. Vr is 800, dm by dt is 200, mass at 5 seconds is 5000. Acceleration will be 32 meter per second square. Next, a rocket of mass 20 kg has 180 kg fuel, exhaust velocity 1.6 km per second, ultimate velocity of the rocket if fuel consumption rate is 2 kg per second. Ultimate velocity means the final velocity of the rocket when complete fuel will burn out. That means initial mass of the rocket is 200 kg. Ultimate velocity is at mass 20 kg. 180 kg is out. So total mass of the rocket is 20 kg now. Use the formula V is equal to U minus GT plus VR ln m naught by m. So m naught is 200, m is 20, Initial velocity not mentioned in the problem, consider it as 0. Gravity 0. So answer is VR, that is 1.6. ln 200 divided by 20, that is ln 10. And value of ln 10 is 2.303. So final answer is 3.7 kilometer per second. Next problem. The first and second stage of two-stage rocket separately weight is 110 kg and the fuel mass is 890 kg. If exhaust speed is 2 km per second, then velocity of the rocket after second stage, and one data is given to you, log base 10 5 is 0.699 and we have to neglect gravity. First, we have to see the starting of stage 1. This is a two-stage rocket, stage 1, stage 2. Mass of the rocket is, stage 1 mass is 100 and stage 2 mass is 10. Fuel mass is 800 and fuel mass in second stage is 90 kg. So what is the total mass, initial mass, starting mass? It is 1000 kg. Initial velocity 0. Now at the end of first stage, you will not have this fuel, first stage fuel. So what is the final mass at the end of first stage? When complete fuel of first rocket will move out. So final mass is 90 plus 10 plus 100. 90 plus 10 plus 100. So final mass is 200 kg. Let us calculate the velocity at the end of first stage. So at the end of first stage, velocity of the rocket is u minus gt, both are 0, plus Vr ln m0 divided by m. m0 is 1000 kg, m is 200 kg. So we will get 2 into ln 5. But the given data is log 5 base 10. So what is the relation between log base 10 and ln? The relation is ln x is equal to 2.303 log base 10x. Right? So you can change this ln 5 into log 5 base 10 by multiplying 2.303. So final velocity is 2 into 2.303 into log base 10 5. This is 3.2 kilometer per second. This is the velocity of the rocket at the end of stage 1. Right? Now in the starting of stage 2, we have to remove this chamber. So we will remove this 100 kg chamber to start stage 2. So what is the initial mass for stage 2? The initial mass for stage 2 is only 90 plus 10. So 90 plus 10 is the initial mass, that is 100 kg. And the final mass is when the complete fuel will burn out. So final mass of rocket after end of second stage is only 10 kg. So initial mass known to us, final mass known to us. This velocity V1 will work as initial velocity for stage 2. So U will be 3.2 kilometer per second for stage 2. Now let us use the formula. It is V equal to U minus GT plus ln m0 divided by m. For second stage, this is second stage velocity. V2 equal to 3.2, that is the initial velocity for stage 2. G is 0, so plus 2 ln m0 divided by m. And m0 is 100, m is 10, so we will get 3.2 plus 2 into ln 10. And ln 10 is 2.303. So when you replace this value with 2.303, you will get 7.8 kilometer per second as the final velocity of the rocket at the end of stage 2. Understood? Next, application number 5, explosion of bomb. In bomb explosion, the total external force acting on the bomb is equal to 0. The explosion is due to the chemical reaction. So there is no external force. If external force is zero, then according to linear momentum conservation, total momentum of the system remain constant. So momentum of bomb before blast and momentum of bomb after blast will remain same. Let us take the first condition in which a stationary bomb explodes into two fragments or two parts. So initially bomb is in rest state. So initial momentum of the bomb before blast is equal to 0. Final momentum will be in two parts because there are two fragments, so there will be two momentums. One is momentum of mass m1 part. Velocity of m1 is v1 and second part is m2. So momentum of second part is pm2 and it is moving with velocity v2. So total momentum after blast is pm1 plus pm2. Initial momentum is 0. So according to the conservation, they are equal. So from this we will get momentum of one part is exactly opposite to other part. So momentums are equal and opposite. You can put the values of momentum. M into V2 is the momentum of second part is equal to minus M1 into V1. This is M2. So M2 into V2 is equal to minus M1 into V1. From this you can calculate the velocity of V2 also, that is minus M1 V1 divided by M2. So this is the velocity of second part. Magnitude wise these momentums are equal, direction wise opposite. So these two fragments will move in opposite direction, right? Now the momentums are magnitude wise equal, so we can say kinetic energy of M1 is P square by 2M1 and kinetic energy of M2 is P square by 2M2. You can calculate the total kinetic energy by adding these two kinetic energies, right? That is the kinetic energy released in bomb blast. Next, second case. A stationary bomb explodes into three parts. Now the stationary bomb explodes into three parts. So there will be three momentums after blast. So initial momentum is again 0. Final momentum will be in three parts. Pm1, Pm2 plus Pm3. All these are vectors. Right? So we can shift this Pm3 to the left side. Then minus Pm3 is equal to Pm1 plus Pm2. Means the sum of momentum of two parts will be opposite to momentum of third part. So what is the vector sum? Magnitude wise they are equal. What is the formula of addition of two vectors? Under root a square plus b square plus 2ab cos theta. So here we have two vectors. So a square is pm1 square, pm2 square plus 2pm1 pm2 cos theta. I am assuming that the angle between these two vectors is theta. This vector sum should be equal to third momentum. So momentum of third part will be equal and opposite to sum of momentum of first two parts. Now let us see the third case. In third case, moving bomb explodes into two parts. So now initially we have some momentum because bomb is moving with some velocity. So there will be some momentum initially before blast. So initial momentum again will be equal to final momentum. Again there is no external force, but in this situation we have initial momentum, that is Pm, and this bomb mass M explodes into two parts, M1 and M2. So capital M is M1 plus M2. So initial momentum before blast is Pm is equal to final momentum after blast. So Pm1 plus Pm2, and this is vector sum of the two momentums, right? Next, let us see some problems based on bomb explosion. First is a stationary shell explodes into two fragments having mass ratio 1:2. So M1 by M2 is given to you 1:2. Heavier fragment attains a kinetic energy 100 joule. The kinetic energy released in the explosion is, so we have to find out the total kinetic energy, we know that momentum of both the fragments are equal and m1 by m2 is 1 by 2. Formula of kinetic energy is p square by 2m. P is same, momentum is same. So kinetic energy ratio is Ke m2 divided by Ke m1 is equal to m1 by m2 because of inverse relation. Now this ratio is given to you 1 by 2. That means m2 is heavier than m1. So if m2 is heavier, its kinetic energy is given to you 100 joule. That means this is given to us 100 joule. So Ke m2 is 100 joule, Ke m1 we have to calculate, and this ratio is 1 by 2. So from this you will get kinetic energy of mass m1 is 200 joule. So what is the total kinetic energy released in the process? It is 100 joule of heavier mass and 200 joule of lighter mass. So total 300 joule is the total release of energy. Right? Next, a body at rest explodes and breaks up into 3 pieces. 2 pieces having equal mass fly off perpendicular to each other, okay, with same speed 30 meter per second. 2 fragments are having same masses and their speeds are also same and they are perpendicular to each other. Now the third piece has 3 times the mass of each of other pieces, okay. Find magnitude and direction of velocity of the third. Okay, so we know initially the bomb is in rest state. You can assume it as a bomb. It's written body, but we can assume it as a bomb. It is in rest state, so initial momentum of the bomb is equal to 0. And here we have 3 fragments. Out of 3, 2 are having equal mass, so I am assuming m1 and m2 both are having mass m. And the third is 3 times of mass of other. So third mass is 3 times the mass of each of other pieces. So third mass m3 I am assuming 3m. So 2 masses m and the third one is 3m. These 2 are moving perpendicular to each other. So here m and m, this is m1, this is m2. They are moving perpendicular to each other. For our comfort, I am assuming this mass is going towards x-axis and other mass is going towards y-axis. So velocity of this mass is 30 I cap and velocity of this mass is 30 j cap. We don't know the velocity of the third mass. So final momentum will be m1 into v1 plus m2 into v2 plus m3 into v3. Final momentum will be m into 30 I cap plus m into 30 j cap plus 3m into v3. Now before blast and after blast momentums are same. So initial momentum is 0. Final momentum you have to put it here. After solving this, here 3 will cancel out, m will cancel out. So v3 here we will get minus 10 I cap minus 10 j cap. And its magnitude is under root 10 square plus 10 square, that is 10 root 2. So magnitude of velocity of the third mass is 10 root 2. Now let us calculate the direction. So for direction, let us draw the velocity v3. v3 is minus 10I minus 10j. So minus 10I minus 10j, that means in third quadrant. So in third quadrant, this is 10, this is 10, then tan theta perpendicular upon base. So this angle is 45 degree. This angle is 45 degree, that means V3 is exactly in the middle of these two axes. This angle is also 45 degree. From first mass, the velocity of third mass is making 90 plus 45. This is 90, 90 plus 45, 135. Similarly, from second mass, it is 90 plus 45, again 135. So third mass is moving at an angle 135 from the other two masses. Right? Next problem. In this problem, a bomb of mass 1 kg is thrown in upward direction with speed 100 meter per second. After 5 seconds, it explodes into two parts. One part of mass 400 gram goes down with speed 25 meter per second. What is the speed of the other part? G is already given to you, 10 meter per second square. Now whenever you throw a ball or bomb in upward direction, the speed of the bomb or ball will decrease due to gravity. And explosion of the bomb is at t equal to 5 seconds. So first of all, let us calculate the velocity of bomb just before the explosion. So just before the explosion, 5 seconds, velocity is v equal to u minus gt. Initial velocity is given to you 100. After 5 seconds, 100 minus 10 into 5. So 100 minus 10 into 5, 50 meter per second is the velocity of the bomb before explosion. And after explosion, we have two masses. Out of 1000 gram, 400 gram will move in downward direction with speed 25. Because it is downward direction, so I am taking negative sign minus j cap. That is showing this part is going in downward direction. And we don't know the velocity of remaining 600 gram. Right? So let us conserve the momentum. Initial momentum before the blast, final momentum after the blast. Now, initial momentum is mass 1 kg or 1000 gram. 1000 gram into 50 upward. So it is 50 J cap. This is the initial momentum of the bomb just before blast. Final momentum after the blast is 400 gram is moving in downward direction. So minus 25 J cap. 400 into velocity is minus 25 J cap, and 600 is going in some direction we don't know. Let us take velocity v2. So 600 into v2. Now solve it. This 100 will cancel out. Here you will get 500 and here you will get minus 100. So when you move it to the left side, it becomes 600 J cap is equal to 6 v2. So velocity of second part 600 gram is 100 meter per second J cap. J cap means upward direction. So answer is 100 meter per second upward direction. Next, second question. A shell is fired from cannon with speed v at an angle theta with the horizontal. So this is a projectile motion basically. And this bomb or shell is projected at an angle theta with velocity v. Explodes into three pieces equal masses at the highest point. So at the highest point, it explodes into three parts, three equal parts. So that is why I am taking total mass of the bomb is 3m. And this 3m mass of bomb explodes into three equal parts, m. Now what is given to you? They are saying one piece falls down vertically. That means this mass is having zero velocity. Falling freely means just after explosion, this part will have zero velocity, while the other part retraces the path. That means it is going in backward direction, retracing the path. Find the speed of the third piece. First of all, whenever it is given retracing the path, that means it is having a backward velocity v cos theta. Because if the bomb moves in forward direction, then it will have v cos theta velocity at the highest point and it will follow this path. If bomb is having v cos theta velocity in backward direction, then it will follow this path. So the second part is having velocity minus v cos theta in backward direction, and you can say I cap, minus I cap. So we know the velocity of the two parts. One part is having zero velocity, falling freely. Second part, retracing the path, means backward direction v cos theta, minus I cap. Now, what is the initial momentum just before the blast? Bomb is at highest point and its velocity is v cos theta. At the highest point of projectile motion, velocity of the particle is v cos theta, horizontal component only. Now 3m mass and velocity v cos theta, so total momentum is 3m v cos theta I cap just before the blast. After blast, we have three parts. So final momentum is m into v1 plus m into v2 plus m into v3. v1 is 0. This is initial momentum equal to final momentum. v1 is 0. v2 is moving in backward direction with velocity minus v cos theta I cap. And the third velocity v3 we don't know. So let us put v3. m into v3 is the momentum of third part. Now conserve the momentum. M will cancel out. This is minus v cos theta I cap, move to left side. Then we will get v3 as 4v cos theta I cap. That means this third mass is moving in right side with velocity 4v cos theta. That is our answer. Right? Next topic is equilibrium of particle. We have two different types of equilibrium condition. First is translational equilibrium, means net force acting on the particle is equal to 0. Second is rotational equilibrium, means net torque acting on the particle is equal to 0. In this chapter, we will discuss only translational equilibrium, and rotational equilibrium we will discuss in rotational motion. So, if net force acting on the particle is equal to 0, then body will be in equilibrium condition. Net force 0 means upward force will balance downward force. So, magnitude of the force acting in upward direction will be equal to magnitude of the force acting in downward direction. Similarly, right hand side force will balance by left hand side force. So magnitude of right side force will be equal to left side force. Means the net force acting on the body is equal to 0 and body is in equilibrium condition. Now let us see some important points related with equilibrium condition. First, single force cannot keep a particle in equilibrium. If we have only one force, then net force is non-zero. So body is not in equilibrium condition. Second, minimum number of equal forces required to keep the particle in equilibrium condition is 2. So we need minimum 2 equal forces to get net force equal to 0. We will take the examples of this condition. Third is minimum number of unequal vectors. Here they are equal and here unequal vectors or forces required to keep the particle in equilibrium condition is 3. So equal vectors we need 2 only. Unequal vector we need 3 vectors. Let us take example of 2 vectors. So to get 0 resultant, we can use F force in this direction, right side, I cap you can say, and F force in opposite direction, that is minus I cap. If you add these two forces, you will get 0 resultant. Means F1 plus F2 is equal to 0. That means F1 vector is equal to minus of F2 vector. Magnitude wise, these two forces or vectors are equal, but direction wise they are opposite. So if you apply two equal and opposite forces on a particle, the resultant force will be 0 and the body will be in equilibrium. Now let us take 3 coplanar forces. I am taking a simple example. These are in the same plane. 1 Newton, 2 Newton, the resultant is 3 Newton. And if you apply 3 Newton in opposite direction, the resultant of the 3 forces will be equal to 0. And we have a special condition for resultant of 3 forces equal to 0, that is Lamis Theorem. According to Lamis Theorem, if 3 forces are acting in this way such that the opposite angle of F1 is alpha, opposite angle of F2 is beta, opposite angle of F3 is gamma, then according to Lamis Theorem, F1 by sine alpha, F1 by sine of opposite angle, means angle between F2 and F3, is equal to F2 divided by sine of opposite angle, that means beta, is equal to F3 divided by sine of opposite angle. Opposite angle means angle between these two, gamma. So we can use this condition to find out the value of F1, F2 or F3 if equilibrium condition is given to you. Now, if three vectors are forming a closed loop, then again resultant is equal to 0. Means F1 plus F2 plus F3 will be equal to 0 if they are forming a closed loop or we have this condition. Now, if net force is equal to 0, then the vector sum of x components of all the forces will be equal to 0 and vector sum of y components of all the forces will be also equal to 0. That means if net force is 0, sum of x components will be 0, sum of y components will be also 0. Similarly, if vectors are in 3D, then sum of z components are also equal to 0. Now, minimum number of non-coplanar vectors. Here we have coplanar vectors unequal. Here we have equal forces. But here they are mentioning non-coplanar forces required to give 0 resultant is equal to 4. So we need minimum 4 vectors to get 0 resultant. Let us take one example. We have two different planes. This is plane number 1, this is plane number 2. And in plane number 1, we have F1 and F2. In plane number 2, we have F3 and F4. They are non-coplanar forces because they are not in same plane. They are in different plane. If the resultant of F1 and F2 is here A, suppose A is the resultant of F1 and F2. Resultant of F3 and F4 is B. If this A and B are magnitude-wise equal, then they can cancel out each other because their directions are opposite. So we will get resultant of 4 forces will be equal to 0. So if they mention non-coplanar forces, then it will be 4. If they mention unequal forces, then it will be 3. If they mention minimum number of forces to get 0 resultant, then answer is 2. Right? Next point. If an equal magnitude coplanar forces acting at a point simultaneously with angle between adjacent forces equal to 360 by n, then the point will be in equilibrium. Means the net force acting on the particle will be equal to 0. Let us check this condition by taking different values of n. First I am taking n equal to 2. So what is the angle between the two? 360 divided by 2, that means 180 degree. So if we apply equal and opposite forces at a point, means angle between the two forces is 180 degree, then the resultant will be 0. These two forces will cancel out each other. Second, I am taking n equal to 3. If you take n equal to 3, then 360 divided by 3 is 120 degree. That means 3 equal forces are acting at angle 120 degree each. Then the resultant will be 0 because these 3 forces will form an equilateral triangle. You can check angle between the two adjacent forces is 120 degree because this is 60. Because it is an equilateral triangle, so 60 outer angle is the angle between tail to tail. Remember, we have to calculate angle between the two vectors by connecting tail to tail. So we will shift this vector in forward direction and this is the angle between the two vectors. So these 3 vectors will form a closed loop, that is an equilateral triangle. And if you want to find out the resultant by using this condition, then resultant of 2 equal vectors which are at 120 degree is again f. You can check it from vector addition and you can cover it from video lecture also. So resultant of these two is f, and this f will cancel out the third force. So resultant of 3 equal forces at an angle 120 degree will be 0. Now I am taking n equal to 4. N equal to 4 means 360 divided by 4, that is 90 degree. So 4 equal forces are acting at 90 degree each. This force will cancel this force will cancel this force. Or you can form a square by using these 4 forces. You can form a square, again a closed loop, so resultant is 0. Net force is 0. Angle between the two vectors is 90 degree. Right? Similarly, if there are 6 equal forces acting at 60 degree angle, then resultant will be 0, or you can form a hexagon, regular hexagon, again closed loop, resultant is 0. Next, let us see a problem based on equilibrium condition. There are 4 forces acting at a point P produced by strings. If P is in rest state, find out the value of F1 and F2. So this is the point P. These are the two forces F1, F2. There are 2 more forces, 1 Newton and 2 Newton, that is acting at 45 and 45 with this line. Now, resultant is 0. P is in rest state. That means net force acting on this point P is equal to 0. Means right side force will balance left side force. Upward force will balance downward force. But here problem is we don't have any left side force. We don't have any force in upward direction. So let us break the components of 1 Newton and 2 Newton. What is the component of 1 Newton in this direction? It is 1 cos 45. And in this direction 1 sin 45. Right? Now let us divide the component of 2. The component of 2 along this direction is 2 cos 45. In this direction 2 sin 45. Now the total upward force is 1 cos 45, that is 1 by root 2. 2 cos 45, that means 2 by root 2. And left side force is 2 divided by root 2. Now according to equilibrium condition, right side force will balance left side force, upward force will balance downward force. So let us balance downward force with upward force. So F2 is equal to sum of these two. 2 by root 2 plus 1 by root 2, that is 3 by root 2. So value of F2 is 3 divided by root 2. Now right side force is equal to left side force. Right side force is 1 by root 2 plus F1. And that is equal to left side force, that is 2 divided by root 2. So when you solve this, you will get F1 is equal to 1 by root 2 Newton. Right? Next problem. If O is at equilibrium, then values of tension T1 and T2 are X and Y. 20 Newton is acting in vertical downward direction. Find the values of X and Y. Means we have to calculate the values of tension forces T1 and T2. This diagram is given in the question, and 20 Newton is acting in downward direction. This is 60 degree. Then this is alternate angle, again 60 degree. Right? Alternate interior angle. This is 150, this is 60. What is the total angle? Total angle is 360 degree. So 150, this is also 150. 150 plus 150 plus 60 is 360. Right? Now I am using Lamis Theorem to solve this problem because O point is in equilibrium condition. Net force is 0. So T1 divided by sine of opposite angle 60. So T1 divided by sine 60 is equal to 20 divided by sine 150. T2 divided by sine 150. And what is the value of sine 150? Sine 150 is sine 90 plus 60. So that is cos 60. Cos 60 is half. Put in this value and solve it. You will get T1 is equal to 20 root 3 when you compare these two. And T2 is equal to directly 20. These two will cancel out. Right? Next problem. A mass m kg is suspended by a weightless string. The horizontal force required to hold the mass at 60 degree with the vertical. So we are using some external force to pull this m kg mass and we are holding it at 60 degree angle, means equilibrium condition. So there are three forces on this block. One is the force applied by us. Second is the weight that is acting in downward direction. And the third is the tension force that will develop in the string due to these two forces. Now, for equilibrium, upward force should balance downward force. Left side force should balance right hand side force. We don't have any upward force. So first of all, let us divide the two components. This is 60, this is also 60. So what is the component of tension force here? T cos 60 and here T sin 60. So left side force should be equal to right side force. So T sin 60 should be equal to F. Upward force should balance downward force. So T cos 60 is equal to mg. Divide these two equations. You will get tan 60 is equal to F divided by mg. When you solve it, you will get F is equal to root 3 mg. Next problem. A boy is hanging from a horizontal branch of tree. The tension in the arms will be maximum when the angle between the arms is. Here I am giving you the options also, right? Because we will solve this problem from options. Suppose this is the boy and because of the weight of the boy there will be some tension in the arms. We have to find out the angle between the arms, this angle, right? Suppose these are the two tension force. This line is the vertical line. Now half angle is on the left side, theta by 2, half angle will be on the right side according to the symmetry. Now downward there will be weight of the boy. Because upward force is equal to downward force, equilibrium condition, so upward tension force will balance the downward weight. So what is the tension component in upward direction? It will be T cos theta by 2. And there will be one more component in left side, T sin theta by 2. Now similarly you can divide the tension T into two parts. T cos theta by 2. Right side it is T sin theta by 2. These two components will cancel out. Left side force is equal to right side force. Now upward force should balance downward force. What is the total upward force? 2T cos theta by 2. Should be equal to weight of the boy, mg. Now what is the tension force? Tension force is T equal to mg divided by 2 cos theta by 2. So here we have 2 cos theta by 2. Now let us put the angle one by one and calculate for which angle we will get maximum tension. If you put theta equal to 0, we will get mg by 2. So for theta equal to 0, we will get mg divided by 2. I am writing here mg divided by 2. When theta equal to 30 degree, we will get mg divided by 2 sin 15 degree. When we put 60, then it is mg divided by 2 cos 30. Cos 30 is root 3 by 2. And if we put 120 degree, we will get mg divided by 2 cos 60 degree. 120 divided by 2 is 60 degree. Cos 60 is half. So for this we will get mg tension force. And out of these four, this mg is maximum. So maximum tension force will be when the angle between the two is 120 degree according to the four options. Next problem. Two light strings of length 4 cm, 3 cm are tied to a bob of mass 500 gram or you can say half kg. The free ends of the strings are tied to the pegs. These two are the hooks you can say. Same horizontal lines separated by 5 cm. So these two are the strings 4 cm, 3 cm. And these two strings are connected with the roof at distance 5 cm. Now what is the question? Question is the ratio of tension in the longer string, that means T1, to that of shorter string, that means T2. So here we have to find T1 by T2. Again equilibrium condition, downward will be the weight, upward will be the tension components. So let us find out the angles. This is a standard right angle triangle, 3, 4, 5. This angle is 90 degree. 5, 3, 53 degree. In basic mathematics, you can see this standard right angle triangle. This is 53, this is 37. We have to remember these angles. So this angle is also 37. This angle, this is 53 degree, this angle is also 53 degree. Now for equilibrium, left hand side force should be equal to right hand side force. So what is the component of T1 along left side? It is T1 cos 37. What is the component of T2 along the right side? It is T2 cos 53 degree. Now according to equilibrium condition, left side component should be equal to right side. There will be two components in upward direction also, but that will balance weight. I am comparing left side force is equal to right hand side force. So T1 cos 37 is equal to T2 cos 53 degree. So T1 by T2 is cos 53 divided by cos 37. Cos 53 is this angle 3 divided by 5 base upon hypotenuse, and cos 37 is this angle base upon hypotenuse 4 divided by 5. So when you divide these two, you will get ratio 3 divided by 4. So our answer is 3 by 4, right?